Hi, in this video, we want to take a look at connecting item response theory with factor analysis. Okay, so the big idea here for this video is that if I have a factor analysis model, then I have a direct connection with item response theory using logistic regression. Okay, and that really is the whole point of this video that we're going to go over. Now, the example here is taken from Modern Psychometrics with R, and here it's from Springer, and here is the modified code if you want to go over what I'm doing here. Okay, so the connection between item response theory and factor analysis is logistic regression. So you can look at item response theory as logistic regression using factor analysis to model correct or incorrect on like a binary test for individual items. Now here, each individual item would be getting its own logistic regression model where the factor is the predictor variable. Okay, so in item response theory, we have our discrimination and location. In factor analysis, logistic regression, we're gonna have slope and intercept. All right, so the discrimination is going to connect to the slope, and the location with a little bit of alteration will connect to the intercept. All right, and the slope and discrimination will also connect to the loadings in the modeling of the factor analysis. All right, so in both of in the two models, slope in the logistic regression is equal to the discrimination, which is equal to the loading for the factor analysis. The intercept in the factor analysis logistic regression model is going to be equal to the negative of discrimination times location. All right, so it's not quite the same, but there is definitely a direct connection there. And this boils down to how are we going to parameterize the model? And so the difference is really just how do we interpret what's going on? The item response theory way is more natural for the situation where I want to be just a generalization of a race model. But if I want to be more direct in relation to logistic regression, then I want to use the slope intercept format. You know, depending on what we're doing, depending on which one for our problem is an easier one to interpret and which one that we just feel more comfortable with. All right, so we're going to run through an example. So let's go ahead and load the data. We're going to use the RWDQ dataset from the MPsychoR package. And in another video, I ran through modeling and came to the conclusion that the first item really doesn't fit well with an item response theory model. So we're going to go ahead and get rid of the first item. And I'm going to call the resulting data matrix M. That way it's nice and compact, easy to work with. Now, something about the LTM package, if I'm going to use its functions with using double colon notation, and so like here, I'm going to be doing double colon LTM. So that way, why do I do this? I don't want to load the entire package. I just want the parts of the package that I want to use. Why do I do this? I do this to prevent package confusion. So remember, when you're working in R, like different packages can use the same name for different functions. And so if I'm calling a function and I've got a whole bunch of packages loaded, I can get confusion about which version of that function name I'm using. So what I prefer to do, I prefer to only use the functions that are part of my project whenever possible. It isn't always 100% possible, but here it is. But I have to get the GH like object from the LTM package. And this has a bunch of values to that the function uses. It refers to as it does its computations. All right, so what we're going to do, we're going to use LTM from the LTM package. We're going to say that all the responses that we have from the RWDQ dataset depend on one factor, and we are going to parameterize in the item response theory method. So here, the ITR parameterization and item response theory parameterization true. So I want this in the item response theory like schema. Now I can do the same thing using the same function, same package. I am saying that everything in the M data set depends on the first factor. So this is going to be the same. Now the difference here is I'm saying item response theory parameterization false. All right, so what this is going to do, this is going to parameterize everything in terms of a factor analysis model. Okay, so now what I want to do, I want to check, are these in fact similar parameters? Are these the same? Is it doing what I am claiming it does? Let's take a look. All right, so you'll notice right off the bat, the discrimination parameter, so these two are coming from the item response theory version, and these two are coming from the factor analysis logistic regression model. And I notice that discrimination and the factor coefficient are exactly the same, at least rounded to 2 digits. There might be a little bit of digit difference, but in terms of significant difference, there's no difference. Now, remember, it's going to be difficulty times location. If I remember, I have to double check it. No, it's discrimination. Intercept is equal to negative discrimination times location. And so, if we do the multiplication, we can see that it'll work out. And you notice that all of these are negative, positive, negative times a positive is a negative. And remember, we have that negative value in the formula. So everything is working out the way we want it to. All right, so now I claim that these are equivalent, that mathematically these are the same. They just have different representations of their parameters. Let's verify that. Okay, so let's go ahead and let's get the individual factors of the people who took the questions, took the survey, took the test. All right, so what I'm going to do, I'm going to get the factor scores out, and I'm declaring here I want the item response theory version. Here I want the factor analysis version, and I'm getting the actual first factor estimation for each of the subjects. Okay, and now I'm going to ask, are they identical, true or false? If they're identical to each other, then it's going to say true. If they're not, it's going to say false. And it says true. So yes, in fact, these are mathematically equivalent to each other. They just have different presentations. So if I need one or the other, I really have both in this situation. So we can look at item response theory as a generalization of factor analysis. This is very nice for us. This shows that factor analysis is truly a very powerful tool in our tool belt. Well, that's all I've got for you. Next video, we'll be going over item response theory where we use multiple factors. Take care and goodbye.